Okay, we're going to continue on and talk about the parabola in a little bit different of a light. Recall that the definition of a circle is sometimes worded in this awesomely mathy way, where it says, and I'm reading up at the top, the set of all points, right, is a circle, that are equidistant from a point called the center. So when we define a circle, that's one way to say, okay, well, it's all the points that are exactly the same distance away from this point in the middle called a center, right? And those are our radius lengths all around the outside. Well, a parabola, instead of just saying, oh, it's a cool U shape that goes up by perfect squares, this is the mathy definition for a parabola. So, I'm so sorry. The set of all points that are equidistant from, not a center, right? This is not a circle. But in this case, we're going to call this a fixed point, and its name is the focus. Okay, so we're going to work on that a little bit today. And a fixed line, which is termed as the directrix. So let me explain a little bit about what that means. It's really hard to draw just freehand, but let's kind of look at this. Now let's say that we have our graph here, and maybe I should actually give it some life here. 1, 2, 3, 4, let's go 5. 1, 2, 3, 4, 5. And when we're looking at this, what I'm going to do is I'm going to draw in a focus and a directrix. And you don't have to put this onto a coordinate grid to start with. Clearly I can't talk and draw tick marks at the same time. But I just will, just to kind of show us what we're looking at here. So let's say the directrix is just a fixed line. So I'm just going to draw a line on here. Well, I'm going to give it my best shot. Let's say we have a line here that's coming through. Whoop, okay, that's a line. That's the line y equals 2, right? It's just flat right there at 2. And let's say that we have our focus point, which is going to be the point, let's go over 3 and let's go up 4. So let's say that this guy right here is going to be the focus, okay? Now, if I'm trying to draw a parabola in relation to the focus and the directrix, the parabola is the set of all points, right, that are equidistant from those two things. So, for example, if I want to draw a point that's equidistant from those two things, maybe I would come right here at 3, 3, right? Notice the focus is 1 unit above, and the directrix is 1 unit below. Now those little red lines are going to bother me, but you can see that that unit right there, or that distance, right, is 1, and the distance below is also 1. So that is equidistant, okay? Now it's a little bit harder to do going off to the right, but if we were to draw all the points that looked equidistant from our focus, so let's say we drew one here, and that should be the same distance there now as it is from here. Wow, that actually looks pretty good. That distance should stay the same. So if this is D, whatever that is, right? To me, it looks like it's a little over 1. That's also going to be D there as well. And we could do the same thing, right, with our symmetry coming down this side. And all of these points, so this guy right here, that point on the graph should be the same distance away from that focus. Now, obviously, this would be a different D value, but it would be the same distance away from the focus as it is from the directrix. So when we plot these points, now often it is hard to determine that just freehanding it. But we can use the focus and the directrix to actually build a parabolic equation, and I'm going to show you how to do that. The way that we do that is we're focusing specifically, I'm going to choose a different color so I can look at this, maybe green, is you're looking at essentially the focus, right? The vertex, that guy hasn't changed at all, that's the vertex of our parabola, and then that directrix down here. Okay, one thing that I want you to notice, and I'm going to kind of write this off to the side so we remember, is that the parabola, okay, it always wraps around the focus. So the focus has to be on the inside of the parabola. If the focus is here, the parabola looks like this, right? Or the focus could be here and the parabola is facing down. Or the focus is here and the parabola is facing to the right. But it has to be on the inside of the parabola. That being said, the directrix is opposite. The parabola never crosses the directrix. So if the parabola is going up, that would be my directrix. On this middle one, if the parabola is going down and the focus is there, the directrix is here. On this third example, if the parabola is facing to the right, then the directrix, right, is the same distance away, but in that opposite direction. So your directrix is opposite, but the same distance away as the focus would be from that vertex, right? My picture does not look that way. Going back to these little green dots I drew on the left, essentially what we're doing is we're looking at this distance right here to help us to build our parabolic equation. And that distance right there we actually call P. So when we're looking at P, okay, P is the distance from the focus to the vertex. Okay, so in this case, my p-value would be 1. It's 1 unit away. Now, the directrix is also 1 unit away, so you could say that p is the distance from the directrix, that's an x, to the vertex as well, right? It's the same. So this p-value is kind of what we're going to use. Now, the p-value obviously relates to like the stretch or the shrink of the parabola. So it's going to actually connect to our a value. So you'll notice if I want to create an equation, the equation I'm going to draw here, and I'm going to maybe I'll put it in blue, is going to look like this. So y is equal to, now that should look familiar, but instead of writing the a value, I'm going to put 1 over 4p. Okay, now again, that p value represents the distance from the focus to the directrix. The rest of this is going to look the same. X minus h squared plus k. Notice that's still just my vertex form, right? Or like we did on the previous video, maybe our x and y's are switched. This is a horizontal parabola, but again, we have 1 over 4p, but this time y minus k squared plus h. Okay, so again, your goal is to be able to go forward if you know the p-value and build the equation, or take the equation, identify the p-value by looking at that a value right there, and then be able to find the focus and directrix. Okay, those are our two goals. So let's do a couple examples that allow us to do that. The first one, let's look at if our vertex was at 3, 4. So let's try and build this equation. Okay, example. Let's say if vertex is at 3, 4, okay, and the focus is at 3, 2, write the equation. Cool. Okay, so if we want to write this equation, again, we need to figure out what that p-value is. And it helps to draw a little picture to determine which direction it's opening, right? So maybe I'm going to draw a little picture first. So I'm going to come over here, and it's never a bad idea to just draw a little picture of your parabola. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now it didn't ask me to graph this one specifically, so I don't need the graph to be fantastically beautiful. I just need to get a good idea of what's happening here. So again, I'm going to plot this vertex. The vertex is over 3 and up 4, so it's sitting right here. And I'm going to put a V by that just so I remember that's the vertex, because now we have a focus and other things. So there's my vertex. The focus here, right, is at 3, 2. So if I come over here and I go over 3, but I only go up 2, this guy right here is the focus. Now remember, again, I'm not graphing this one. It didn't ask me to, but I'm going to draw kind of a rough sketch. So the focus is below the vertex. And remember, the parabola has to wrap around the focus, which means this guy must be opening down. And that means that we're going to be using our y equals, right? It's an up or down one. And then notice that we can also find this p-value. So if we look at this distance right here, it looks like that's 2 units. The focus is 2 units away from the vertex. So that's going to be the p-value. And again, if we needed to, we could draw that directrix, right? The directrix would be 2 units up here. We could draw that little directrix right there. He would be at, it looks like 4, 5, 6. Okay, so we can kind of connect all those pieces. All right, we're writing our equation. So we're going to start with y is equal to, now it's opening down, so I'm already going to put a negative right there. I just know that that's already a negative. And I'm going to put 1 over 4 times p. Again, here's your p-value that you're putting in there, so the p-value is 2. And then everything else comes off of my h and my k from my vertex. So you're using that vertex up there. The vertex is going to be h minus 3 squared plus 4. Okay, and then we'd probably simplify that, so we'd write y equals negative 1/8 x minus 3 squared plus 4. So that would be the equation whose vertex is at 3, 4 and has a focus of 3, 2. Okay, let's look at another example. Let's say we're looking at one where we have the vertex, again, at negative 2, 3. And let's say we know that the directrix is x equals negative 5. Okay, again, we're going to draw a little picture and just make some sense of this first. So here's my graph. We draw this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm sure you're grateful for my counting. Okay, from there, I'm going to plot these things. So let's go for the vertex first. So negative 2 up 3. Negative 2 up 3. 1, 2, 3. Cool. And again, I'm going to put a little v by it so I know that's my vertex. So there's my vertex. Then my directrix is at x equals negative 5. Now remember, x equals would go up and down, right? Undefined slope. So my directrix is actually right here. Right there. That guy's x equals negative 5. So this one, remember, the parabola goes away from the directrix. So this one must be opening to the right. So we're not asked to draw this one, so I'm just rough sketching it here. But this one would look something like this. It's going to open to the right. And again, we need the p-value. So if we want to find the p-value here, we've got a lot of green going on. The p-value is this distance. So it looks like we're 1, 2, 3 units away would be our p-value. So we can start to build our equation. Right? We can look at this and we can say, okay, it's opening to the right. So that means I'm going to use this guy up here, right? I'm going to have an x equals. So we're going to go x equals 1 over 4p. Now, the reason I didn't use a negative on this one is because it's opening to the right. Right is positive on the x-axis. And then we put in our y minus, remember your k goes in there with the y, plus h, but in this case it's negative 2, so we're going to put negative 2. So there you have it. X is equal to 1/12. Y minus 3 squared minus 2. Okay, so given different information, again, the goal is to be able to connect them. So if we were to look at one, maybe let's look at one that combines the last one. Oh, we still got room. Victory. Okay, let's look at one where we're given the equation. So this one, let's determine the focus and directrix. Given the equation y is equal to 2x plus 1 squared minus 3. Okay, So looking at this one, determine the focus and directrix. So remember, and the biggest thing to remember here is that the vertex will be like the same, right? So my vertex here, Yahoo, is just -1, -3. The p-value, so that I can figure out where my focus and directrix, notice this guy's opening, let's look at the front here. If we look at this front piece right here, right, he's opening up because the y and the x, they're in their normal spots, and this is positive. So we know it's going to open up. Oop, oop. And we know that the vertex, right, is here at like -1, -3. So we're just kind of making sense of it. And then to find that p-value, right, we got to use this 2. So we know that usually it's 1/4p, but that's equal to 2. So in this case, if I were to solve that, right, it's like multiplying by 4p on both sides. So it looks like 1 is equal to 8p, divide by 8, and p is equal to 1/8. So we know that the focus is 1/8 away from the vertex, and so is the directrix. So you do need to look back and decide. Notice that the focus is above the vertex, okay? Above and below is your y value, so you're going to add p if you want to find the focus, and the directrix must be underneath the parabola, so you're going to subtract p, and that will take you down to the directrix value. Okay, and directrix is y equals, because it's a flat line. So you can either add 1/8 if you're more comfortable with decimals. This one is a nice decimal, right? 1/8 is the same thing as 0.125. So if we want to identify this, we would just say, okay, well, the focus, right? We're going to take this -3 right here, and the focus is still going to be at -1. It's just moving up or down. And we're going to add p. So if we add 1/8 to that -3, we get -2.875. And then for our directrix, we're going to subtract p. That takes us down below. So we get y is equal to -3.125. So we can find our focus and directrix. Okay. I'm going to do one more. I know this one's getting long, but I want to make sure that we kind of understand where this is coming from. Oh, I guess I have to add a page because that's a thing. Okay, so looking at this one, let's graph the parabola. So this guy right here, graph the parabola, and its focus and directrix. Okay, so let's say we're given this parabola. X is equal to -3/4. Will be a good a value. Y plus 4 squared minus 1. Okay, so the first thing that we're going to do is we're going to identify maybe the vertex. If I want to graph this, oh, maybe I should draw my graph. Let's do that. All right, here we go. Whoop. Okay. Again, you're looking at the things that you need. You need the vertex to graph this, and you just practiced this in the last video, is just graphing with the a value, and you can do that if you're comfortable with doing 3/4. Where you can identify the different parts, so we can look at that. So let's do that first. Let's just identify our vertex, okay? So we've got our x and y axis already over there for us to graph. So our vertex here, again, don't get tricked. This one, the x and the y are switched. So remember the vertex comes from, oh, I just got tricked. My h here and my k here. So we know that's our vertex. So -1, I'm going to plot that down 1, 2, 3, 4. We know the vertex is right there. So I'm going to label that V. Again, this is negative out front. So notice here it's negative, which means this guy is going to open to the left. Okay, and I'm just going to make note of that so I remember it. And then I also know that it's being shrunk right, by 3/4. So if you want to just use the a value to graph, you can do that, right? We know that if it's 1 unit away, instead of going 1, it's only going to go 3/4 the distance. 1 unit away, 3/4 the distance. 2 units away, normally it would go 4 units forward. But in this case, 3/4 of 4 is actually just 3. So we're going to go here. So we're going to go here. So I can actually draw my parabola, right? We were good with drawing parabolas before we knew vertex and focus, or directrix. So we've already got our parabola drawn. Check, did that part. Now we just need to graph the focus and directrix. So we need to find that p-value so we know where to graph those. We know the focus is going to be in here somewhere, and the directrix will be over here somewhere. We just got to figure out where that is. So we take this front part, right, to find that p-value. So 1 over 4p, and we set it equal to 3/4. Now I already know it's opening to the left, so I don't need to throw the negative in there. And let's do some cross multiplication. So we get 12p equals 4. Divide by 12. P is, sorry, I skipped steps. It looks like it's going to be 1/3. Okay, so notice over here, my vertex is at -1, -4, and my focus is going to be this direction. So notice your y value is not changing because it's a horizontal parabola. It's your x value that you're adding the p to. So in this case, I'm going to take this x value, and I'm going to subtract p to move it left, and that's going to give me the focus. And then I'm going to add p to give me that directrix to the right. So in this case, it looks like that my focus, if I subtract p to that -1, I'm going to end up with -4/3. -4, right? Because you have -1, then you subtract another 1/3, and that gives us 4/3. Okay. And then if I wanted to find the directrix, again, that's going to be 1/3 in the other direction. So that's going to be like x equals -1. If I add that third is 2/3. Now again, this one just asks you to draw it, so I didn't necessarily need to write it out, but we can draw. We're going to go 2/3 of the way, and this might get a little messy, but 2/3, yikes. And I'm going to label it just to make sure we know what that means. And then the focus was just 1/3 this direction, right? So there's my focus, and that focus point was already given. So that's graphing. So that's the focus and directrix, playing with those vertical and horizontal parabolas. I will post a partial key for the homework. There's only 11 problems, I think, because they take just a little bit more thinking. But just make sure you're kind of using your notes and playing off of those, being comfortable with finding that p-value and understanding what that means.